Your complex, detailed, many-parameter model is created from sampling of the world, and the world elsewhere, unseen by your model, might be very different. You've captured too much complexity. Remember KISS, keep it simple, stupid, or Occam's razor comes to mind. How do we get that kind of simplicity, that abstraction we need, that ability to generalize if we're overfitting, if we're too detailed, if we're too complex? Well, firstly, there's a situation where lots of parameters, lots of detail, lots of complexity might actually be very good. That's in the world of hyper-parameterization, where there's more parameters than data points. You end up with something called benign overfitting. In benign overfitting, there's so much complexity, there's actually quite a lot of crosstalk between all the parameters, and chaos ensues. And chaos is almost like injecting randomness or injecting noise into the model. It actually supplies some breathing space. But what if overfitting is a problem for you and all those biases, those training scars and fallacies are being amplified? How can you improve your lot? One thing you can do is carefully prune your model, prune away those excess parameters. How do you do that? Well, you can use causal path analysis. So you did your regression analysis and you discovered associations and relationships and correlations. But with augmenting that with path analysis, you can just prune away those parameters which might actually not really be causally relevant. Another thing you can do to help is cross-validation, which is a little bit like how in statistics you can go back to resample from the overall population, from the real world repeatedly to get more samples. In machine learning, you fold up the training data into training data and test data, and then each side of that fold you use repeatedly, iteratively, so that you can make the most of the training data to get the most samples out of the training data. This helps you to maybe train out those problems caused by overfitting and generalize better. And next you can go for regularisation techniques, which penalize complex models, such as least absolute shrinkage and selection operator, or Lasso, which basically shrinks the importance of the least important parameters. One thing I've not mentioned previously is that parameters often have weights, and weights are just that. They give the parameter heft or not. The heavier parameters have more importance. If you reduce the weight of a parameter down to almost nothing, it's almost like getting rid of that parameter, or at least you could reduce its effect on the model. That's what Lasso can be used to do.